Hello everybody, welcome into the very first lesson of geometry. I'm excited to have you all as we start this next adventure in the math. So, as I've said in yesterday's video when I welcomed you to geometry, geometry is very different from algebra in a lot of ways. Sure, geometry has some algebra in it. All you really need is Algebra 1 experience. So if you aren't experienced with Algebra 1, I would encourage you to please review my Algebra 1 playlist where I explain all those concepts in great detail. Going into this course, I'm going to assume that you're okay with Algebra 1 topics and that we don't need to cover it. But that's definitely not going to be in today's lesson. There's no algebra whatsoever in today's lesson. It's going to be quite simple. Today we're going to talk about points, lines, and planes, and some other definitions. So let's start out here with what's called a point. Everyone's familiar with a point, right? Usually denoted by a dot. So a dot, a point. It's that simple. That's a point. It has 0 dimensions. It is literally just nothing. And a dot has no thickness or no real size, but it's just denoted by a dot. So that's something to note about a point. Has no real thickness, has no real size, but it's usually denoted by a dot. And when we classify points, they're usually classified by capital letters. So I'll call this point A. Okay, I'll call that point A. I'm going to keep point A up there because it's going to tie into our very next topic here. We have now point B. Well, whenever you have 2 points, they can always be connected with a line. They are always connected with a line. So running through any 2 points in both directions endlessly, a line goes on forever in both directions, you have a line. Alright, so a line, like a point, has no real thickness or no size. Well, I mean, yeah, it has none of those, but it's denoted by, well, a line. Lines they can be named one of 2 ways. You can name it with a lowercase letter. So if you see a lowercase letter, that usually denotes a line. That would be line L. Or you can name it by points on the line. You may also see something such as AB, because a line has to have a minimum 2 points, and it will have a small line symbol above it. If you see a small line symbol above the 2 points, AB, that means that's called line AB. So that is a line. Now we're going to take this a step further. Of course, a line is 1 dimension. That's only in 1 dimension. Now, hypothetically here, let's say I drew around it here. I drew this big box around it, okay? And I put some point that's off of line AB. If I put some point that's off of line AB, I put some arbitrary point C. We have now a whole plane. This would be called a plane. P-L-A-N-E, a plane. So, a plane is also denoted by a capital letter. We'll call this plane R. Planes traditionally are represented by parallelograms or quadrilaterals, but anything can represent them. Planes go on infinitely in all 4 directions, so there really is no end to a plane either. And planes as a result, you think about this logically, if planes extend infinitely forever and ever, they have no edges. It looks like they have edges because I only drew a good portion of the plane, but in actuality, this plane is going on forever into existence. That, you know, that where our eye can't even see it. So a plane is the set of points where you have some points on a line and then at least one point that's not on that line. And you could argue a plane has multiple lines running through it. It has infinite lines running through it. It certainly does. And there's an infinite number of points in the plane. Now, one more I'd like to do here. What if I did this, okay? I have another plane here. Let's dash this line a bit because I want to illustrate these two planes intersecting. I would like to do that. So, there, that's much better. I have another plane, we'll call that plane S. And I'll put some random point on this plane called point D. We'll have some random point on plane S called D, point D. When you have two or more planes come together, because a plane's already got a bunch of infinite points on it, when you have more than one plane come together, that's called a space. So planes are 2D, right? Planes are 2D, and they can be represented by a wall, by the ceiling, by the floor. But when you put all those together, I have the space of a room, like I'm standing in right now. That's the space. The space is truly the collection of all points. In the room I'm standing in, not only could you put points on the wall, you could put points in the middle of the air. You think about it, there's points in the middle of the air. There's an infinite number of points. So that is what a space is. Okay. Now I'm going to go back to lines for a minute. So we've covered the basic context of points, lines, and planes, and we talked about space also. Let's just deal with line AB for a minute. Just good old line AB. Okay. Well, of course, AB forms a line. Let's put some point C in between AB. I have a point C now in between A and B. Or C could have been to the left of A, it could have been to the right of B. It wouldn't matter. If all three of these points lie on the same line, those are called collinear points. So when points all lie on the same line, those are called collinear points. Now if I put a point D somewhere above the line or outside of the line, then if I were to try to say all 4 points are collinear, that would be a false statement. You actually get here what's called called noncollinear points. If all the points aren't on the same line, then you have noncollinear points. So that's pretty simple. Linear, of course, we could think of like line. When we did linear equations in algebra, and the graph of it was a line. So linear, line, that kind of helps. It goes hand in hand. Now, let's draw this plane back again. I'd like to draw that back again. This time, let's say I plot a point D. We'll call this point R. We'll call this plane R, okay? I have points A, B, and C on line L, but in the same plane, in plane R, I have point D. If the points all lie on the same plane, those are called coplanar points. Those are coplanar points. So A, B, C, and D all lie on the same plane at the very least. Those are coplanar points. Now, what if I'm going to draw another plane again. I'm going to intersect plane R. I certainly am. And again, we'll call this plane plane S. The green plane we'll call plane S. And we'll put some arbitrary point E on plane S. Now, if I were to try and say that points A, B, C, D, and E are coplanar, that would be a false statement because point E lies exclusively on plane S, where in point B lies also in S at this point, since it's point E for sure lies on plane S. My drawing's a little skewed because I'm trying to draw 3D and 2D, and I'm not Bob Ross, in case you all haven't figured it out by now. But the point of the story is here, if all the points don't lie on the same plane, those are called, what the heck is, noncoplanar points. Alright, so yeah, if all points don't lie on the same plane, those are noncoplanar points. So, I think that's simple enough to understand. Now, let's scrap the planes for a minute here, okay? Let's talk about intersections. Let's talk about some intersections here. So, let's say I have a line going this way. I have point A here. I have point B here. We'll call this line L. Then I have a line that intersects here and goes through here. I'll have point C on this line, point D on this line, and then where they intersect, I'll call that point E. And we'll call this line here, we'll call that M. Okay, so now I have two intersecting lines, L and M. They intersect at point E. The intersection of the lines is only the point, or it's only the point that both lines have in common. So, for example, point A is only on line L. It has nothing in common with line M because it's not on line M at all. Just like point D, it's only on line M. It has nothing to do with line L because it's not on there at all. But point E, being the intersection of the both lines, it's on both lines. Point E is on both lines L and M. So that's the, or you could say intersect. You could say the lines intersect or intersection, however you prefer to say it. And yeah, you guessed it. Just like lines can intersect, so can planes. Planes also intersect too. So let's draw some planes here. Again, I'll call this plane plane R, our first plane. Okay, now let's draw another plane here. Whoops. I prefer to do that in a different color. I think that would make more sense so you could see it better. Alright. Go up to that point, draw it dotted. Alright, so we have another plane running through this plane. We could call this one plane S. So planes R and planes S intersect at this line. We'll call this point A. We'll call this point B. So you can say that R intersects S at line AB, which would just be AB with that little line symbol over it. So plane R intersects plane S at line AB. So notice two lines intersect at one point, two planes intersect at a whole line. So that's something different. And we'll get into more theorems and postulates about that as we get further into the course. But right now I'm not going to. Today's just going to be a real basic definition day. It's not going to be anything too crazy. So now I'm going to draw. Here's what I'm going to draw. A couple lines. Let's draw a couple lines here. Let's lower this a little bit. There's a reason I want to do that. I have my reasons for it. It's going to help us with the drawing, okay? So right there I have two lines. These two lines intersect at point O. On this line you have T, this line you have W, so you have TOW on this line. On this line here you have point R, on this one here you have point S. Now, what I'm about to do is draw a plane around this. Let's draw a nice plane around these. And then, yeah, we'll call this plane plane M. This is plane M. So far, all these points are coplanar because they all rest on the same plane, but we're about to change something here. Let's see. I'm about to draw a line. All right. XY. Okay. We got points X and Y. So now what we have here is we have everything on plane M, and then we have a line that runs through the plane XY. We have line XY that runs through plane M. It runs from the top down through below the plane. So what we're about to do for the next 7 exercises here is we're just going to do some true and false statements. So the statement's either going to be true or it's going to be false, and I can explain why. Alright, and notice something first, because you're probably wondering, well, what if a line intersects a plane or a plane intersects a line? It still intersects at a point. It only intersects at a point if you have a plane and a line. So I'm sure that's plain to see here from this diagram at point O. Alright, so let's see here. First statement. Line XY intersects plane M at point O. Alright, so is this a true or false statement? Line XY intersects plane M at point O. Let's take a look at this. Here's line XY, and right at point O, that's right where it meets plane M. So yes, this is actually a true statement. We have line XY does in fact intersect plane M at point O. That would be a true statement. And I got 6 more questions, and it's all based on this diagram, so it's going to be incredibly easy. The reason for true and false statements a lot in geometry also is to get you into that deeper thinking. Because algebra, it was like you were given methods and this is what you use every time. Geometry calls you to step outside of the box and really analyze what you see. And even argue technicalities sometimes. So geometry can be fun. Alright. How about this one? Plane M intersects line XY at more than 1 point. Okay, so the statement they just gave us now is that this plane M intersects line XY at more than 1 point. Is that true or false? Well, let's look at the diagram again. It looks like line XY only intersects plane M at point O because above O, it's truly above the plane. Below O, it's below the plane. So it actually intersects at only 1 point. So that makes this statement false. It does not intersect at more than 1 point. It intersects at only 1 point. So that's why that would be false. All right, what's the third one here? Let's see. Referring to points T, O, and R are collinear. So let's see. This is referring to points T, O, and R, and it's saying that they're collinear. So are points T, O, and R collinear? In other words, do they lie on the same line? Well, let's look at this here. Here's point T, here's point O, but then there's point R on a separate line. R is clearly not on point on line with TO. So this is a false statement. We have a false statement. TO and R are clearly not collinear. They're on different lines. All right, how about the next one? X, O, and Y are collinear. So it's stating that points X, O, and Y are collinear. That's actually a true statement. They all lie on the same line. So in this case, the statement is actually true. They are collinear. All right. Let's see. R, S, T, and X are coplanar. So now this is making a statement that points R, S, T, and X are coplanar, which means on the same plane. Well, R, S, and T are clearly on the same plane. They're on plane M. But if you look at point X, it's hanging out above the plane, which means it's not on plane M. So therefore, these are not coplanar points, so the statement is actually false. So the answer is for this one, this is actually a false statement. Okay, we got one more and that's it. Let's see. R, X, O, and Y are coplanar. So let's see. This statement is that points R, X, O, and Y are all coplanar. Let's take a look at this. Here's R. Well, here's O. R and O are definitely coplanar, right? They're on plane M. But X and Y are both on a different plane because point X is above the plane, point Y is below the plane. So this is also a false statement. They are not all coplanar points. So that statement is actually false. So that covers this lesson about points, lines, planes, space, collinear points, coplanar points, intersections, stuff like that. Next lesson, we're going to get a little bit more in depth with lines, different types. We're going to talk about segments, rays, and distance. So I hope everybody has a good night. Take care.